Saxon Algebra 1/2, lesson 73. Today, you guys, we are going to talk about the way to measure right circular cylinders. What the heck is a right circular cylinder? Let me use this as an example. It's a can. The base of it is a circle. Oh, circular. The sides of it go kind of straight up from the base. They form a right angle where the side and the bottom meet. That is a right angle. Oh, right circular. Cylinder means it's three-dimensional. Now, this one's not perfect because you know how there's like a little ridge on this edge and the top has weird little indentations on it. We're not going to deal with such primitive imperfections, you guys. Our right circular cylinders are perfectly smooth and even, and they're made out of cardboard like, you know, the containers that oatmeal comes in, oats, not oatmeal, but like the raw oats with the Quaker on the outside, that one. That's what I'm talking about. They're perfectly flat and even, and they're made of cardboard. Now, take one of those canisters of oats and some imaginary box cutters, and we're going to use those to find the surface area of a right circular cylinder. Now I'm going to draw one. There's the circle that's the base. You could have a cylinder that's based on an oval, but ours are based on perfect circles. Pretend this is perfect. It's not. What we're going to do is we're going to cut off, with our box cutters, we're going to cut off the top. That's going to give us a perfect circle. Then we're going to cut off the bottom. That's going to give us a perfect circle. I'm not drawing them perfectly, am I? Pretend. Then we're going to have a tube, aren't we? Like kind of like a paper towel tube where you can look all the way through it. What we're going to do is we're going to take our box cutters and we're going to cut along there. And we're going to open that tube, and what we're going to have is a rectangle. It's made of magical cardboard that as soon as you lay it flat, it will stay perfectly flat. You know how regular cardboard, it would curl right back up again? No. And those are the sides, or what we call in the math world, the lateral surface. Okay, lateral means sides, right? The muscles in your sides are called your lats. Yeah, laterals. Okay, so when we're finding the surface area of a right circular cylinder, we have to find the area of the top, the area of the bottom, and the area of the side rectangle. And that allows us to calculate, we add all that together in order to calculate the total surface area. Now, what's interesting about this is that John does not call this an actual problem. There's no example in this lesson. He just works it, but doesn't tell us what it is. So what we're to assume, what we're to work with in this problem, is that the radius of the circle, measured like so, is 3 inches, units, measures, what? Meters. And the height, this is the height, is 20 meters tall. Wow, that's really tall, isn't it? It's a very large circular cylinder. It might be a gigantic dunk tank, although 20 meters would be quite a dunk tank. Okay, you could really do some deep sea diving in that one. Okay, so what we do is we figure out then, for what I like to do is I don't like to write the words, I like to draw the pictures. The area of this, the area of a circle equals pi r squared. And so that's going to be, in our case, 3.14 times 3 squared is 9, which equals, let's do that over here, 3.14 times 9 28.26 meters. Okay, and we're going to do that twice, right? Whoops. 28.26. One for the top and one for the bottom, right? That same shape repeats itself. Okay, so we don't have to calculate it twice, we just use that. Then we need the area of the rectangle. Now we see that, and that's length times width, right? Area of a rectangle equals length times width equals, now, one of these dimensions is going to be 20. This dimension is 20, right? Because that was the height. I'm going to call that, it doesn't really matter what order I put them in. That's 20. That's this way. Now we have to find this dimension. Now, here's where it gets tricky. This dimension used to be wrapped around the circle that we cut off and are now calling the top, right? That matches exactly to this, right? Just as if I want to find the dimension, let's measure from this line here. If I want to find the length of the rectangle that would come if I cut the tin apart right there and made that into a rectangle, this, the top of that rectangle, is the same as the circle. So if we find the circumference of the circle, that will give us the length of that side of the rectangle. Weird, right? So we have to find the circumference of the circle. Circumference is 2 pi r. I don't know why I memorize it in that order, but I do. 2 times 3.14 times the radius is 3. Okay, so that is 3.14 times 6, right? 2 times 3 is 6. So the circumference of the circle equals 18.84. This does not say says circumference of a circle, area of a rectangle. That's what my little abbreviation thing there is. All right, so the circumference is this measure. So now we can multiply 20 by 18.84. And that will give us the area of the rectangle. So let's do that. It's 18.84 times 20. That's the height. I'm doing the little trick where I let the 0 hang off. And then I can just copy it and multiply the rest. 376.80 is the area of the lateral surface area, this bit. Now we add. I wrote this wrong, didn't I? That should have been a 6. You've probably all been dying over that. Well, I struggled away on my other numbers. Okay, 6 plus 6 is 12. 5 plus 8 is 13. 16, 22, 23. 2, 4, 6 plus 7 is 13. Is that the right answer? Yay, that's the right answer. Meters squared, always a unit. Surface area is a square. So that's the secret to doing the surface area for a right circular cylinder. Volume, so this was the first part. Volume does not require a new formula. Area of the base times the height. The base, I'm just going to draw it over again. The base is a circle. And we've already found the area of the base for our previous calculation. Sorry, I'm turning the page. The area of the base we found to be 28.26. right? Which we said it was pi r squared. And our radius on this is still 3, and our height was 20. It's the same shape. 3 is the radius. Okay. So 28.26. Sorry, I'm writing this in a wonky fashion. All right, and so then all we have to do is multiply that times the height. Which is 20. Let the 0 hang off. I'm just looking to see, because John doesn't format this as an actual problem. I don't even see that he did this calculation to find the surface area. Oh, John doesn't actually work this problem. This is the volume. We put 2 decimal places back in, and it would be meters cubed is the volume. Because we already have worked volume problems before, I guess he doesn't consider it important to do it for this problem. But I did it, and that should be right. I can't double check that answer with my calculator, but it's the area of the base. Our radius is 3, so that's pi r squared, which would be 3.14 times 9. And that's correct. I'm just double checking to make sure. Yes, and then we multiply it by the height, which is 20. Okay, that should be right. Yay, that's all there is to lesson 73. And again, it's really the surface area that we're working on here. So, can of oatmeal, the cardboard kind, cut it apart, look at the shapes, and find the area of each one. Yay. Happy end of lesson 73.